sort of directory is really interesting, that takes advantage of Snakemake and takes it all to a whole different level, and part of why I think is really nice and successful. You can always clone this repo and run your things, but you can see what I like about it is just the organization. So at the base they got a snake file, and they got different directories, workflows, scripts, tests, profiles, things that are defaults, your data, and so on and so forth, right? And I just wanted us to sort of look a little bit. It's a bit advanced, but we're gonna just have a look through. So the snake file here is an interesting one. A bit advanced, but I think for people who do Python, it's it's not all that. Very nice commenting, and everything is well written out. You can see the config files in the default parameters where they set all the parameters. You can see lots of Python work. Yeah, it's not the easiest to go through, but I think with time and you get experienced, you can you can go through it, right? And you can see the rules. They got they run this. Imagine they run this a couple of times, I think, in a week, and it does all these and does all the cleaning and so on and so forth. And you can see a directive here. This is the main snake file, and it is calling other snake files getting included in. Lots of rules and stuff. Yeah, I'll zoom it. Zoom, that works now. I think it's the NCOV one. A bit lost. Let me do this. I want us to go to the workflows directory, and you go to the roots, and you go to the main workflow. It's really nice if you're sort of a SARS-CoV person, and you can borrow quite a lot here. How they download data from GISAID, sanitize, making quite a lot of use of Python functions, running their benchmarks, specifying the code environment, the logs, the parameters, and the params are all in the config files, specifying your memory limit, and the shell command, which is a script called sanitize metadata that takes in your metadata, the columns as input, the database, and the fields that they are going to be renamed from sort of the defaults in GISAID, strip the prefixes that are not necessary, and write your output metadata. Okay, and it's really nice. I mean, so it shows the alignment, a rule align, where you're aligning your sequences, reading all your sequence data using quite this scripts here, the configs, where to write your outputs in the results folder, and you can see something similar to what we were learning today, and all the params in here, the log files, benchmark, and the threads and resources. Yeah, and this is the script. This is a Python script again for sanitizing, and takes in all the input, and over here the output of this is piped into next align, which does the alignment and takes in the jobs. The jobs are from the threads parameter at the top, and outputs everything, and then runs these commands to compress the alignment, because they can be quite large, and it's very generic. Okay. So meaning that you can work across. So I mean, you can go through it a bit advanced, but I think for someone who's written Python or wants to do something similar, can take a lot of lessons. So we'll take a break, go for lunch, and then when we come back, we will go through the this Second, practical, which is about distribution and reproducibility. And thereafter, we will again look at how you can make use of the HPC and a couple of more practicals, and then we call it a day. Okay? So, right.